Hello everyone and Assalamualaikum to everyone that watching this video. Today our group will presenting about question 1 for LAB3, which is input output programming using the Raspberry Pi microcontroller on the Maker Pi Pico board. So this experiment which is focuses on controlling LEDs and piezo buzzer using push button inputs through a C++ program developed in IDE Arduino. So here's our group members, which is first you got me myself, which is Muhammad Araf bin Arsham. And then you got my fellow partner, which is Muhammad Ahmad bin Abdullah Zamawi. And we got my other partner, which is Muhammad Daniel Hakim bin Nurul Shahrazi. So our group to work together on the programming, hardware implementation, testing, and also presenting about this project. So this is our objective for this lab, which is first we got to develop a C++ program for the Raspberry microcontroller. Then second, we got to observe the operation of LEDs and buzzer using push button inputs. Then the third one is to determine the response of the system under different input condition. So before we go further ado, let's take a look about the question. Just we got the question 1 for this lab 3. So before we go further, let's take a simple look at this question, which is here we got process A, which is switch 3 is pressed. The odd LEDs blink for 1 second, and the buzzer on for 2 seconds. So the next part, which is process B, we got switch 4 press, even LEDs on 2 seconds and buzzer on for 4 seconds. And for the third one, which is we got both switch are pressed, so all LEDs blink for 0.1 second, buzzer on for 3 seconds. So this experiment is to determine whether the input and the output are correctly detected. Okay, so here's our flowchart. This flowchart shows the overall operation of our program. The program begins with the start block and proceed to initialize the RP2350 microcontroller. So during the initialization, all LEDs and the buzzer are configured as output devices, while switch 3 and switch 4 are configured as input devices. So after the initialization, all LEDs and the buzzer are turned off to ensure that the system starts to in a known condition. Next, we move to the controller, which is microcontroller continuously reads the status of switch 3 and switch 4. So the first decision we make is that switch 3 is pressed. So if switch 3 is pressed, the program execute process A, which is where the odd LEDs, namely LED 1, 3, 5, 7, blink every 1 second, while the buzzer is activated for 2 seconds. So if switch 3 is not pressed, what will happen? The program checks whether switch 4 is pressed. So we go to the next, which is if switch 4 is pressed, the program execute process B, which is even LEDs are turned on, which is we name as a LED 2, LED 4, LED 6, and LED 8. Turn on for 2 seconds while the buzzer remain on for 4 seconds. So what if switch 4 is not pressed? So the program checks whether both switch 3 and switch 4 are pressed simultaneously. So we go to the next decision, which is if both switches are pressed, the program executes process C, where all LEDs blink rapidly every 0.1 seconds and the buzzer turns on for 3 seconds. If none of these conditions are met, the system enters the no switch press state, where all the LEDs and the buzzer remain off. So after completing any process, The program returns to the repeat block and continuously monitors the switches for the next input. So if anything input comes, the microcontroller automatically give the output for this program. So that's it for flowchart. I give it to you, my groupmates, which is Amma.
Now I will be talking about the codes for this lab. So we have the line 2 and 3 is for the to assign the pin of the switch 3 and switch 4. So switch 3 get assigned to pin 20 and switch 4 get assigned to switch 21. Then we have buzzer which is assigned to pin 18. Then we have the LEDs which is assigned from 0 to 7. Then we have the lines 8, 9, which means that the the switch is actually high. At high, then it will be low when you press. And um, we also makes the buzzer always remains low when it's not pressed. Initially, it's low. Then we have the line 14. This is for the LED from 0 to 7. So this is checks the current set the current LED as LED SI. Then we will turn the current LED which is low. Then we have the lines 20, 21, 22, 23. This means that we gonna we put these both switches at low. So both switches at high. So when it is pressed, the switches become low, and it will be stored in boolean. Then we, as the checking, so we put a small delay of 50 milliseconds, and we will recheck it in line 30 and 31 to see if a switch has been pressed. So then we're gonna show the third condition when both switches is pressed. So when both switches is pressed, the buzzer will turn on, and LED will be flashed for 15 times. All eight LEDs will flash. Then the LED will be remain turned on for 100 milliseconds. Then it will be turned off simultaneously. It will be and the buzzer will be turned off after the sequence is complete. Then we will look at the condition 1. When only switch 3 is pressed, the buzzer will be turned on, and the loop, which as you can see, integer j equal to 0, j less than 8, j plus equal to 2. This is to make sure that the even LEDs is turned on, which is 0, 2, 4, and 6. Then it will be delayed for 1000 milliseconds. Then the LEDs that are turned on, the even LEDs will be closed, and the buzzer will be turned off. And we will look at the second condition, which is only switch 4 is pressed. Uh, then, as we know, the buzzer will be turned on. Then we will look for integer j equal to 1, j less than 8, then j plus equal to 2. This means that the LED that will be turned on is of the odd number, which is 1, 3, 5, and 7. Then the delay will be 2000 milliseconds, which is 2 seconds. After that, after the LED has been turned on for the 2000 milliseconds, it will be turned off. The odd LEDs will be turned off. Then the buzzer also will be turned off. So that's all from me. Thank you.
Hi, my name is Daniel, and I would like to continue with discussion and result. First, I would like to explain to you about the result in regarding our experiment. There are three conditions, but we wrote as four. First, there is no condition, which is no switch was pressed, and also resulting no LED activity and no buzzer is on or activated. And then moving on to our first demonstration from the video, which is switch 3 was pressed. On the board it says GP20, and resulting that odd LEDs, which is LED 1, 3, and 5 and 7, blink every 1 second, and the buzzer on for 2 seconds. And moving on to switch 4 pressed, which is on the board it says GP21. When it press, even LEDs, which is 2, 4, 6, 8, on for 2 seconds, and the buzzer on for 4 seconds. Lastly, we press both of the switch, which is GP20 and 21, also indicates as switch 3 and switch 4. All LEDs blink every blink every 0.1 seconds, and the buzzer on for 3 seconds. Okay, now I would like to explain to you about discussion. The experiment was successfully completed, as all LED patterns and buzzer activation times operated according to the given requirements. The microcontroller processed the push button inputs and control the LED and buzzer through its GPIO pins. Results demonstrate the successful implementation of digital input-output interfacing and timing control using C++ programming in the Arduino IDE. Thank you. Lastly, for conclusion, the experience has fully demonstrated input and output programming using the microcontroller, which is RP2350. The push buttons were used as digital inputs, while the LEDs and the buzzer acted as output devices. Different LED patterns and buzzer activation times were achieved based on the button conditions, as I told you from the result, which is GP20 and GP21 indicates switch 3 and switch 4. The results obtained match the program requirements, proving that the RP2350 can effectively control external hardware through GPIO programming. And the experiment also improved understanding of microcontroller interfacing, digital I/O operations, and timing control using Arduino IDE. And that's all from all of us. Thank you.